Okay, I think the class is being recorded now.
Yes, sir.
Okay, fine. So as we are saying, so I made mention of the so-called allo group, right? Allo group, right?
Yes, sir.
And I said something. I said something about the allo group. That the allo group. What are those family? We call them allo. They are halogen family from our periodic table, right?
Yes.
The fluorine, right? The chlorine, the iodine, the
Astat.
bromine, iodine, and what? And astatine.
Astat.
So how you call them when you have them as a substituent in your organic chemistry. This fluorine will be called fluoro. What fluorine?
Bromo.
More iodo and what? And
Ato.
and acetone. Right.
Astato.
So I will just give you an example when you have them as organic compound. So for example, when we have something like this, and don't forget that I told you that the carbon to carbon single bond, they belong to alkane family, right? Do you still know that?
Yes, sir.
Yes, sir.
Exactly. So now if you have this, you have hydrogen,
Are you recording the class?
you have hydrogen,
They started recording.
Yes.
you have hydrogen, we have hydrogen, we have the hydrogen, we have this, we also have this. Okay, let me just clean this so that to be okay. We'll see it.
Thomas.
So we have this, we have your hydrogen here, also have your hydrogen here, you have your hydrogen here. And don't forget the rule of thumb in organic chemistry that we said the bond that must surround the carbon must be how many?
4.
Or when you count this carbon itself is surrounded by 1, 2, 3, 4, right? This one also 1, 2, 3, 4, right? 1, 2, 3, 4, right? 1, 2, 3, 4. Is that okay? Is that
Yes,
okay?
sir.
Yeah, for this fluorine.
Yes, sir.
So for this fluorine, just mute your mic, please. Khadija, mute your mic. Okay, that's fine. So this one is chlorine, right? And it's a substituent here, right? And this is carbon with 4. And carbon with 4, so far it is alkane family. It belongs to alkane family, right? Because it is carbon to carbon single bond, right? That shows that the name that we end it is ANE. Is that okay?
Yes, sir.
Are we okay with that? Now, and so far it is carbon. How many carbon atoms do we have? We have 1, 2, 3, 4. And carbon number 4 of alkane family is what?
Butane.
Butane. So we already know that this name is butane. Now, but we have a substituent here. Sorry. We have a substituent here. Chlorine here is our substituent, right? Chlorine is our substituent here, right?
Yes, sir.
Yes, sir.
Yes. Now, how do we now count? You count from this side, 1, because it's near your substituent, 2,
Yes.
3, 4, right? Is that okay?
Yes, sir.
But this chlorine is on the position of carbon number what? Number 1, right?
Yes, sir.
So in this case, so far it is carbon number 1. It is some people do call it 1-chlorobutane. 1 what? Chlorobutane. Don't forget that I told you that it is halogen family. What do we call them? We call them bromo, chloro, and iodo, and so on. So, but they do call it 1-chlorobutane because why? Because it is at carbon number what? Carbon number 1, right? So, but this is not actually its name. So they don't call it 1-chlorobutane because you name it. So far, it is on carbon number 1. Anything that is on carbon number 1, you name it. You don't name it number 1. You don't name it 1, except there are other substituents in other carbon atoms, on other carbon atoms. Except there are other substituents in other carbon atoms. That is why you name them. That is why you name them. Are we together? But in this case, we don't name it one chlorobutane. So far, number one is still number one. For example, if you have X, it means that the X that you have, the numbers of X that you have here is one, right? So in this case, so either you don't call it one chlorobutane, you name it what? Chlorobutane. Are we together? That's the name that you name it. So you name it what? Chlorobutane. But if this chlorine itself, this chlorine, if this chlorine is at carbon number 2 and you have this like this, so far your substituent is near this side, so it is on carbon number 2, right?
Yes, sir.
Yes, sir.
In this case, you name it what? 2-chlorobutane. Are we together? So that's the basically on how you name the substituents. Are we together? So now let me just quickly go back to, are we together? Do we need to write it down?
Yes, sir.
Yeah, put it down. Are we done with it?
Yes, sir.
Okay, let us proceed with this. So now, so let me just chip in to the what's it called? The alkyl group. You know, that's the first substituent that we said we have. Okay, who can still remind us the general formula for alkyl group? Alkyl group.
Okay, good.
CnH2n plus 1.
Yes.
Sorry, I think I have the problem of the network. Can we see it right? Can we see the board?
Yes, sir.
Okay. Okay. So fine. Someone said it is the alkyl group. Someone said it is CnH2n. Someone also said CnH2n plus 1. Which one should we follow right now?
CnH2n plus 1.
CnH2n plus 1. So this is actually the alkyl group formula. So now we said it starts from number 1. When n equals to 1, we have C1H2 into bracket 1 plus 1, right? 2 times 1, 2 plus 1, 3. We have CH3. So if we follow homologous series, we know that this one will be C2H5, right? Which is, this one is methyl or methyl, right? This one is ethyl or ethyl. This one is C3H7, which is what?
Pupil.
Right. The next one is C4H9. What do we call it?
Butyl.
Butyl.
Yeah. Yes, fine. So the next one, what was the next one? C5H what? H11. The next one is 6H what? H13, and so on and so forth. So we need to know this thing. It is something that we need to know. We need to know it very well. So we'll just give one example of how we name them. So now we will soon move to IUPAC nomenclature, but after we are done with the types of organic compound that we did in our last class, this one is just a reminder. So, right, when you have something like this, CH3, because sometimes they don't give you, they don't want you to know whether they are talking about the straight chain like this. So when you have CH3 here, so when you have this, so assuming you have this is a compound that you are told to name. So how do you name them? So in this case,
From the back.
can you see the board, please? Can we all
Yes,
see
sir.
it? Okay,
Yes, sir.
now with this, so we can actually name this compound because we are still coming back to, okay, what are the rules of naming organic compound? We are going there. So, but we just want you to know something about this. This is our substituent, right? It appears to be our substituent, right? So now, how do we now start counting? We either count from the right or the left, but the one that is near our substituent, yes, to the substituent is where we are going to start our counting. So we know that at this point, from this end, is where our substituent is near than that of this one, right? So now, if you want to count, you count from 1, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, right? But if perhaps you want to count from this side, this one will be carbon number 1, right? Carbon number 2, carbon number 3, carbon number 4. Are we together? Are we together? But if you are naming from this left side, right? So our substituent is on carbon number 2, right? And can someone quickly tell me what's the name of our substituent? What's the name of the substituent that we have here?
Methyl.
What's the methyl? And you know that it is on carbon number what? Carbon number 2, right?
Yes, sir.
We said it is 2-methyl, right?
Yeah.
But we'll need to first know something. This is carbon to carbon single bond, right? And it belongs to what family?
Okay.
Alkane family. And it is when you count it, it is on carbon number, it is what? It is 4 carbon atoms that we have here, right? And 4 carbon atoms is what? For alkane, it is what? Butane, right? So our name for this is now what? 2-methyl butane. Are we together? So if you are counting from the right side, your methyl is on carbon number what? Carbon number 3, right? Are we together?
Yes, sir.
How do we name that? What's the name? If you start counting from your right side, from this side,
3-methyl.
it's now what?
3
butane, right? That's the name actually. Yes. So we have 2-methyl butane and 3-methyl butane. You can found these either of both of them. Either you found one of them in the option, or you find either both of them in the option. Which one will you now take? Which one will you now take? So part of the rules.
The first.
Can you hear me, please?
Yes.
Yes, sir.
Yeah. Now, part of the rules of organic compound, when you are naming, when you are doing IUPAC nomenclature, the naming system, part of the rule is that the smallest number, the one with the smallest number is the real name. The one with the what? Smallest number is the what? Is the real name. That shows that 2-methyl butane is the what? Is the real name. Are we together? Are we
Yes, sir.
together? So you need to know that. Yeah, let's quickly put it down and let's move to alicyclic hydrocarbon. Yeah, please, let's be fast. Are we done, please? Okay. Can we proceed?
Yes, sir.
Okay, I didn't go Rocky, but you're not here. So when we were explaining, okay, let me just quickly brief what we've said on this. So I've said something of substituent before that we have the allo group, we also have the alkyl group. So this is methyl. This is methyl. It is one of the substituents that we have, as you know. So, and in organic chemistry, when you are naming, you either name from the right side or from the left side, right? So here, this is our substituent. And part of the rule of thumb of organic chemistry, or how we name a compound, is that where our substituent is, near is where we are going to start our name. So we start naming, we start numbering from the from where the substituent is. We are still going to write the full details on how we are naming a compound. I'm just using this one as an example so that it will be clear to people before we proceed to IUPAC nomenclature. Now, this is a substituent on that this is our substituent. So, and either you start from the left or from the right. So we said when we start from the left side, we said this one is number 1, number 2, number 3, number 4, right? And this is our substituent. So you either name from the left to the right or from the right to the what? To the left. That we numbered from our right also to the left. Now, on this point, we found that methyl is on carbon number 2 when you are numbering from your left to right. From right to left, methyl is on carbon number what? Carbon number 3. Are we together? So now the substituent name is methyl. It is on what? On carbon number 2 when you are numbering from your left to right. That's why we have two. The name of the substituent is methyl, but it is on carbon number what? Carbon number 2. That's why we have what? 2-methyl, right? Are we following, Rocky? So now in this case, so it is 2-methyl, and when you count the number of the carbon atoms that we have, it is 4, and it belongs, since it is carbon to carbon single bond, it belongs to alkane family, right? Alkane family. Are we together? So now, and number 4 of alkane is butane. That's why we have what? 2-methyl butane. But when we are numbering from the other side, that is from right to your left, we found that this methyl falls on carbon number what? Number 3. Right? When you are numbering 1, 2, 3, we found that it falls on carbon number what? Carbon number 3. And when it found, we found it on carbon number 3. So we said, since it is methyl as well, it is 3-methyl butane. We now said you can either found 2-methyl butane in the option, or 3-methyl butane in the option, or both of them. When you found both of them in the option, it is usually common that you found both of them in the option. Which one will you now pick? Part of the rule of thumb of naming organic compound is that, so the smallest number is the real name. The smallest number is the what? Is the real name. That is, the one in which we have the number is very, very small. Is the what? Is the real name. So that's why we have what? 2-methyl butane. Are we together? I'll still give you an example. Let me give you one example more. Let me give you one example more regarding this. Okay? Let's just check this. When you have CH3, you have CH3, CH2, you have C, you have C, you also have C. You have this CH3, you have CH3. You also have CH3. Okay. Assuming we have this and we want to name it. So you need to understand something here. If you are just a slow learner, or you don't actually know what it means by this, you just split this. Split all these equations. Split them. So how do you split them? Number one, you need to understand. So you need to be a fast learner. This is C, surrounded by how many hydrogen atoms? Let's talk.
3.
3. We have
3.
1, 2, 3. That's what it means. Are we together? This, you have C. It is surrounded by how many hydrogen atoms here?
1.
1. That shows that this one is at the up, while we have the CH3 downward, right? You also have another one. You have H, you have CH3. You have C, you have CH3, you also have H, right? You have C as well. You have H, you have H, you have H. Are we together? So H is here. So that's why you need to be you need to vast with what you know as the knowledge. So now, let's check this. You need to know that the bond that must surround the carbon is how many? 4. When you count this, yes, when you count this, it is 1, 2, 3, 4 for this carbon itself. That's fine. It is fine, right? But you count this as well. 1, 2, 3, 4. You need to count them so that you know that if something is missing or not. Are we together? So this one is 4 as well. Yes. This one is 1, 2, 3, 4 as well. 1, 2, 3, 4 as well. 1, 2, 3, 4 as well. All the bonds, they are what? They are completed. They are complete. We've completed everything. So that shows that this is fine. How do we now name? So I don't know. So, but let's go. So someone said it is this name. Let's check whether it is that name as well. So part of the rule is that either start from the right or from the what? From the left.
From the left.
Either from the right or from the left. Let's start from the left here. We have 1, we have 2, we have 3, we have 4, and we have 5, right?
Yes, sir.
If you start from your left side as well, you have 1, you have 2, you have 3, you have 4, you have 5. Now, this is our substituent. This is the substituent that we have, right? Are we together?
Yes, sir.
Yes, sir.
That's just that if you are starting from the left side, you have your carbon, you have your methyl at the carbon number what? Carbon number 2, right? You have methyl at carbon number 2. You have it at carbon number 3 here. You also have it at carbon number what? Carbon number 4,
Number 4.
right? It means that you have 2, 3, and 4.
Mhm.
Abi,
Yes,
Yes.
is that not so? But
yes,
the
sir.
methyl,
Yes,
there,
sir.
how many methyl do we have here?
3.
3. And
Three.
3 in chemistry. 3 in chemistry is what? We have, if it is 1 in chemistry. So if it is
Right.
2, we have di, right? If it is 3, we have
Yes,
what?
sir.
Tri. If it is 4, what do we have? Tetra, Abi, and
Yes,
so on
sir.
and so forth. So why it is 3? It is what? Tri. And what's the name? Methyl, right?
Methyl.
Methyl. And when you count it, there are 5 carbon atoms, right? Which is our
Yes, sir.
longest. So the 5 carbon atoms as the longest chain is what? Is this carbon to carbon single bond. It belongs to alkane family. And what's the name of that alkane family with carbon number 5?
Pentane.
Pentane. So
Pentane.
what? 2, 3, 4 trimethyl what? Pentane. Right?
Yes,
Yes,
sir.
sir.
So when you start numbering from your right to the left, so this, it is also found on, we have methyl on number 2, we have it on number 3, we have it on number 4, right?
Yes, sir.
That's as well, it is what? 2, 3, 4, the same thing. Try methyl what? Methyl pentane, right? Now, if perhaps the number is now different, how do we now get it? So you had all these numbers together. If the number is smaller than this number, the smaller one is what you are going to take. The smaller one is the one you are going to take. 2 plus 3 will give you what? 5. 5 plus 4,
5.
you get what? 9.
9.
If this one is 9 and this one is also 9, that's so that the name is the same thing. So it's actually the same thing. But the fact that when you add it up together, and you found that this one is 10, the smallest one is the real name. The smallest is the what? Is the real name. Are we together?
Yes.
Sir, I don't understand, sir.
Now, I said, now for this name, actually, when you add up this number together, 2 plus 3 plus 4, you get 9, right? When we add these as well together, we also get 9, right?
Yes, sir.
So there is nothing different. That shows that this is the actual name. Both of them is correct, right? If you read that name either from the right to left or from left to right. Are you okay with that? I now said, if perhaps that the numbers, they are different. I'll give you one example now. If the numbers are different, for example, you found that this one is 9 and this one itself is 10. This one is 10. The one with smallest number is the real name, is the one that you are going to take as a what? As a real name. Let me just give you a real example now. When you have something like this,
Hey.
so is this correct? Let's check. Is this correct?
No, sir.
Okay.
No.
What happened there?
No.
What happened?
The hydrogens are not complete.
The hydrogen. Where are we going to put the hydrogen?
The first
First
The
D
four-
and
carbon.
the end.
And last one.
and here, right?
Yes, sir.
Yes.
Okay. Now let's now name. You said we either name either from the left to right, right? If you are starting from this left, We said this one is 1, 2, right? 3, 4, 5, 6. If you are starting from
6,
this, 1, 2, 3,
2,
4,
3, 4,
5, 6.
5, 6.
If you are naming from this side, that shows that we have methyl here, right?
2,
We have it here,
3,
we have it here,
4.
right? That's we have 2,
Yes.
3, and 4,
2,
right?
3, and 4. Yes.
If we are to name from the right side to the left, we have methyl at carbon number what?
2,
Number
3,
3,
4.
Eh?
Okay.
4,
3,
5.
4, 5.
3,
3,
4, 5.
4, 5, right?
5.
Yes, sir.
yeah.
That's where we have it. Abby, let's now name it.
Yeah.
This one is,
Yes.
we have 6 carbon atoms as the straight chain, right?
Yes.
Which is what? Alkane family
Ex-
number what? What's the name?
Exit.
Exit.
Same. We have 2, 3, 4 trimethyl.
Exit.
Trimethyl what? Hexane,
Ex-
right?
Exit.
This one is 3, 4, 5 trimethyl what? Methyl
Exit.
Exit.
hexane. In this case, you are going to see both of them in your option. Which one are we going to take? So what you need to do is that you now add up the number together. 2 plus 3 will give you what? 5. 5 plus 4, you get what? 9, right? 3 plus 4 is what? 7.
7.
7 plus 5 is what?
12.
12.
12. So now, yeah, which one are we now going to take? The smallest number. So that's why they said from the smallest number is the rename. The rename is what? 2, 3, 4 trimethyl hexane. Are we together? Do we all understand
Sir,
that?
please, how are we? How did we get that rate?
Hexane. Hexane
Yes.
is because we have carbon to carbon single bond, right? Carbon to carbon single bond.
Yes.
It means it belongs to alkane family. Are we together?
Yes, sir.
Because when you count the straight chain, we have carbon with 6. We end it at carbon number what? Number 6. And number 6 in alkane family is what? Number 6.
Exit.
It is what? Hexane. Are we together? So that's how we know it. I'm just giving you this one is just a small. We are just using this one what would I say it now? We are just chewing it as a chewing gum. We still have yes, we have some complex. This one is just simple because after giving you the rules for naming organic compound, so you will be good to go about that. So you won't have any problem regarding that. This one is just small thing. There are some things that we need to first do before we just arrive at this answer. But don't worry, we are going to do it so that it will be okay. Oh, yeah, let's put it down. So let's put it down. Can we proceed, please, class?
Yes, sir.
Okay, fine. That's good. So it seems it is very clear. Okay. So now, alicyclic that we said, alicyclic hydrocarbon, alicyclic hydrocarbon. So we said is the hydrocarbon that are formed in what? In rings, right? Right. And I said it starts from number three, that whenever you have, sometimes you will have triangle, they will give you something like triangle. And you'll be wondering that, is this organic chemistry? It is organic chemistry. Oh, if you are given triangle, so it is organic chemistry. If you are given this, your pentagon, if you are given hexagon, it's still your what? It's still organic chemistry. You'll be wondering that, what's this? So if you are given this, it means it is part of what? Alicyclic hydrocarbon. It's part of what? Alicyclic hydrocarbon. What is in between the? We have a joint here, right? We also have a joint here. We also have a joint here. All these joints, it means that it is filled with carbon atoms. You have carbon here, you have carbon here, you have carbon here. This joint as well, here as well, and this as well. This is carbon, this is carbon, this is carbon, this is carbon. Likewise here, one, this is another carbon, we have another carbon here. This is how we have it. Even 7, 8, 9, and 10. This is how you have it. Are we following? Are we together? So now,
Yes,
all these are
Yes,
carbon.
sir.
It belongs to alkane, alicyclic hydrocarbon. So likewise, we have alkane family and so on and so forth. That's how we also have alicyclic. For alkane family, we have alkane, but for alicyclic, we call them cycloalkane. What do I call it? Cycloalkane. That is the carbon to carbon single bond. We have alkene. Alkene is carbon to carbon double bond, right?
yes, sir.
So that we also have cycloalkane. Cyclo what? Alkene. That shows that for the alicyclic, you are going to have double bond there. So likewise, but it is rare to have cycloalkyne. It is rare. You cannot find it. They won't ask you. So it is rare to find cycloalkyne. You
Sir,
either
why?
found, you said why? Okay, you are going to know the why now. When you have something like this, okay, let me just use this example. Okay. Sorry. So now, example, when you have C, this, carbon, this. When you have this like this, and don't forget that we said the bond that must surround the carbon must be how many?
4.
2.
Hey, the bond that must surround the carbon. Someone said it is 2.
4.
4.
It is what?
4.
4.
4. Now, in this case, this carbon itself is surrounded by how many bonds now?
4.
4.
4.
Complete, right?
Yes.
What of this?
4.
4. 4, right? What
Yes,
of
sir.
this?
2.
2.
2. So you have 2. So in this case, you are going to have what? C3, H what? H2.
C3, H2.
And in organic chemistry, they don't prefer hydrogen atoms to be lesser than what? Carbon atoms.
Carbon atom.
Are we together?
Yes, sir.
So that's their normal rule. They don't prefer hydrogen atoms lesser than what? Carbon atoms. Although
One atom.
in some advanced chemistry, you could find these there. But in chemistry, for your level, they don't prefer hydrogen to be lesser than what? To be lesser than
Sir,
carbon atoms. Yeah.
sir.
Yes, ma. I can hear
But
you.
the other C, yeah, it has H, but it's not feasible. That's why. So we can count it as 442.
Which one? Which one are you saying?
The ones you round, you circle
This
them.
triple bond, right?
Yes, sir.
Yes, we count it as 4. We also count this one as 4 as well. But for this carbon, it is only surrounded by 2 bonds, right?
Okay, sir.
These carbon atoms, it is surrounded by these 2 bonds, right? But these, we cannot add another hydrogen to this. So far, the bond that must surround the carbon must be how many? 4. Or what are you asking? I don't understand your question.
Yes, that's it, sir.
That's okay. Now, for this carbon, we have what? We have 2 hydrogen. So with this, making it 4. Are we together? So now, so I said it is, you can name it, but actually, so in chemistry, they don't prefer your carbon atoms to be what? They don't prefer your hydrogen atoms to be lesser than what? The carbon
Carbon
atom.
atoms.
Are we together? So that's why homologous series, we do consider homologous series very well. So definitely, if it should be, cycloalkane is another family entirely.
Yes, sir.
Yes.
Yes, if we should have, okay, let's just check this. If it's going to follow homologous series. Let's check alicyclic with triple bond with 4 carbon atoms. Are we together?
Yes, sir.
So this is number 4. We have carbon, we have carbon, we have carbon, we have carbon. Assuming this one has triple bond, right? For this one, we have
I
C.
can see your screen.
You cannot see it.
Yes, sir.
It's probably your
Sorry.
network. It's probably your network. Okay, let's check this. We have triple bond, right? So this carbon is surrounded by, the bond is complete, right? 1, 2, 3, 4. This carbon, this as well. Are we together?
Yes, sir.
But this is
Yes.
surrounded by 2, right?
Yes, sir.
Yeah. So if we should put hydrogen and hydrogen here, as well as this hydrogen and hydrogen here. Are you following, please?
Yes, sir.
Yes, sir.
Yes, sir.
So what do we have? We have C4, H what?
H4.
H4.
Now, when you check this with homologous series, does it follow homologous series?
No.
Right.
No, sir.
Why it is no? What is homologous series? The
Homologous series.
two consecutive member are differ in molecular formula by what?
Formula of CH2.
CH2.
When you
Molar mass
remove
of
this from this, you have C, right? H4 minus H2,
H2. H2.
as you have H2. So these are 2 consecutive members of cycloalkyne, and they are still differ in what? In molecular formula by what? By CH2. So it follows homologous series. But for this
No.
level,
I don't understand this place.
do we understand?
No,
Someone
sir.
said I don't understand. Hey,
Yes, sir.
Rocky, you don't understand, Abby?
I don't understand as well.
At all.
Yeah, only this one. That's C and C4H4.
Do you understand how we get C4H4?
Yes, sir.
You understand
Yes,
it, right?
yes.
Yes,
Okay,
sir.
this is what we get. And I said, someone asked a question. Is it Amida?
Yes, sir.
Okay. Amida has a question that, okay, why do we said we don't actually found cycloalkyne normally? I said you can find it in some textbooks, but for our level now, they don't consider it as normal chemistry, because in chemistry they don't prefer hydrogen atoms to be lesser than what? Carbon atoms. Are we together? So we now say, let us check the example. We have cycloalkyne, right? So we now check the example that, okay, for example, if we have triple bond in alicyclic, how do you go about it? So we check carbon number 3, which is this. We found that when we add the triple bond, we said we have C3H2. For carbon number 4, we have C4H4. I now said, if you want to know if this compound truly exists and is part of a family in organic chemistry, you check their homologous series. You check their what? Homologous series. If their homologous series, if the two consecutive member, if they are differ, someone said I can't hear. It's your network. Can we hear me?
Yes, sir.
So it means that Rocky, it's your network, please. It's your network. You can log in and you can log out and relog in. If you can hear, let me just know. Should we proceed?
Yes, sir.
Yes, sir, we can proceed.
Okay, in this case, I said if you want to know if this compound is truly real, so you check the homologous series. So if the two consecutive member, if they are differ in molecular formula by CH2, that shows that it truly exists. Are we together?
Yes, sir.
But our level, they don't prefer having these. And I've told you why we don't have them for our level here. So now, we now check C4. This is the two consecutive member in cycloalkyne. Cycloalkyne, that is with triple bond. So C4 minus C3, we have C, right? H4 minus H2, what do we have?
H2.
H2. So that shows that both of structural goes means truly all these compounds, they exist. Are we together? But for our level, they did not add it to our syllabus. It was not added.
Okay.
So that's why I said, okay, for the smart learners, we just need to expose you to this, that okay, you cannot find it in your textbook, but chemistry you could find it. Are we together? So just note that.
Yes, sir.
You can also put it down. So please, let's
Sir,
put
what
it
is
down.
the
Ma, I can't hear you.
sir, what is the name? Can we call it
What's the name?
cyclobutyl?
Okay, we need to know. Okay, don't worry. I'm going to tell you the name. Okay. Tutor, sir. You raise up your answer. Hello, sir.
Oh, assalamu alaikum.
Walaikum salam.
Is Ali Daya using his?
I can't hear you.
I said it's Ali Daya using his
Okay,
page.
you are the one using
Yeah.
his. Okay. You have
Yeah.
the question, right?
Yes, sir.
Okay, what's the question?
I said that if you are to write the alicyclic hydrocarbon in molecular formula rather than the structural formula that you just drew, how is it going to be? How can you differentiate it from the normal?
Okay.
Do you understand
Now,
me?
I understand you that instead of writing, do we have a formula for alicyclic hydrocarbon? That's what you mean, right?
Yeah, yes, sir.
Okay, I actually understand your question. So, Amida, do you have any question before we move?
Yeah, I said the naming.
The name of the question, okay? The name of the compound. So for this one, I'm going to answer your question, Ali Daya. So the name of this compound is that's why I said I'm going to give you the rules, but you are going to name it now. I'm going to give you the rules of naming organic compound. Don't worry. So now for this, so when you are naming alicyclic, you start from where the triple or double bond is. Either you start from here or you start from here. It now depends on the substituent. It now depends on what? The substituent. If you have a substituent here, if you have a substituent on this carbon that we have CH3 here, that shows that we are starting on this carbon. If you have a substituent here, that shows that we are starting from this carbon. Are we together? But in this case, this one is cyclopropine. What do I call it?
Cyclopropine.
Cyclopropine. So this one will be what? Cyclobutane. Cyclobutane. Are we together? This one is cyclopropine. Why this one is cyclobutane? Do we all understand?
Yes, sir.
Okay, that's fine. So going back to Sister Idaya question. So do we have a the formula that we need to we are going to use to know the alicyclic hydrocarbon? Actually, we don't have. Why? Because there are some organic compounds that they have the same isomers. I said it in our last class. For example, cycloalkane and alkane. Are we together? Are we together?
Yes.
Okay, let me just give you
Yes, sir.
cycloalkane and alkene family. They are of the same isomers. That is, they have the same formula. They go with the same thing. That's why we don't have a formula for alicyclic, because we know that some alicyclic, they have the same formula with the normal alkane family or alkyne. For example, when we have something like this and we have something like this, this one is surrounded by two bonds, right? Is that not so?
Yes, sir.
We have two hydrogen that remains, right? This one is surrounded by how many bonds?
3.
How many hydrogen do we need to add to it?
Wow.
1. What of this one?
2. 3. 3.
We need how many hydrogen?
3.
We have 1, 2, 3. So, Ali Idaya, are you with me?
Yes, sir.
So when we have something like this, so this is surrounded by 2, right? 2 bond, right? We need to add 2 hydrogen, right? So we have this. We also have this as well. We have this. We also have this as well. When you count the carbon atoms, the carbon number atoms here is 3, right? The hydrogen atoms here is how many?
3, 2.
The hydrogen atoms here. How
5.
many hydrogen? Count it now.
It's 6.
It is 6, right? Likewise, this one as well. When you have something like this, you have the carbon atoms is what? 3, right? C3. How many hydrogen atoms do we have here?
6.
We have 6 as well. We found that these, together with these, have the same numbers of carbon atoms as well as the same numbers of hydrogen atoms, right?
Yes, sir.
So could we now say the general formula for alkane should be used for cycloalkane? Actually, it is no. So that's why we don't consider it as the same thing. We just say they belong to the same isomers. Are we together? You can easily say they are of the same isomers. You just know, you need to know the rules that, okay, how do we know cycloalkane? How do you know cycloalkane? How do you know cycloalkyne? Which I've explained. Are we okay with that?
Yes, sir. Thank you, sir.
Okay, no problem anymore. Okay?
No,
Right.
sir.
Okay, so they are of the same isomers. So when we reach isomerism, we are going to know that what kind of isomerism is between cycloalkane and alkene family. So we have different, I will just tell you now, because this one is cycle, you know, it is cyclic. This one is cyclic, right? Why this one is straight chain? So the isomers that is between both of them is chain cycle isomerism. What do I call it? Chain cycle isomerism.
Chain cycloisomerism.
So chain cycle isomerism is between both of them. Okay, Ajayi, what's your question?
Okay, sir. Where you are naming the second one, the one with the straight bond, straight line. Start with HH. Why did you start from the bottom and you don't put hydrogen at the top of the second one?
Where? Which one?
Because the 1, 2, 3, 4 is complete.
I mean the second one.
Second one, Abby?
Yes. This
Yeah,
one.
right? Okay.
Yes. Why did you put the hydrogen at the bottom and not the top?
Okay, why do I put it? You can either put it either top or at the bottom. So anywhere you can put it. Just know that it should be just one hydrogen. Are we together? Not that there is any rules. Is that clear?
Yes, sir.
Is that clear? That's fine. So thank you very much for that. So can we proceed? I think you all understand, right? And it is very clear. This is quite different from the previous class. So very sorry for that previous class for moving faster. So I think there is something I'm doing that time. So I need to be very fast on that.
Yes, sir.
Okay. Should I rub it off or we should proceed or I should wait till you draw it?
Rub it off.
Okay. Okay, some people are drawing it, right?
Yes, sir.
Okay, you can screenshot it so that you can come back and draw it because we have limited time now.
Okay, no problem, sir.
Okay. So that's alicyclic hydrocarbon. So now let's go to aromatic hydrocarbon. Aromatic hydrocarbon. When you said aromatic, the word arrow, you will see that it is aroma. It's something that is sweet. So aromatic hydrocarbon.
Use for the last slide.
I can't hear you. You cannot perceive it, right?
I can perceive it too.
Okay. So when we said aromatic hydrocarbon, aromatic hydrocarbon, it has characteristics that we can use to identify, and it has only one example. It has what?
One example.
What example do we have for aromatic hydrocarbon? The example is just one, which is benzene. What do I call it? Benzene. So that's the only example that we have for aromatic hydrocarbon. So that's the only example that we have for aromatic hydrocarbon. Are we together?
Yeah.
That's fine. So the benzene.
I did not finish the definition.
We'll tell you the definition. Very sorry, I'm coming over, please.
Okay, sir.
No problem, sir.
Okay. The aromatic hydrocarbon. Let's write. Aromatic hydrocarbon possess the following characteristics. It possesses the what? The following characteristics.
The following characteristics.
Number one, they are cyclic and planar. They are cyclic and what? And planar.
And planar.
That's number one.
And
Number
what's
two,
that?
planar. You
Planar.
can find it on the board. I've written it there. They are cyclic and what? And planar.
Planar.
Planar is not planar, so planar.
So
That
what's
is they are
planar?
plane.
Okay, plain.
Planar. Planar.
They are plain.
Yes.
Okay, sir.
That's number one. They are cyclic and planar. Number two, they possess delocalized. They possess delocalized. Okay, sorry, I made a mistake. I named delocalized. They possess delocalized pi electron. Pi what? Electron.
Electron.
They possess delocalized pi electron. Number three, they follows Huckel's rule. They follows what? Huckel's rule. Huckel's rule. That's Huckel's rule. They follows what? Huckel's rule.
Okay.
Okay.
So that's the characteristics that
Aromatic
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 hydrocarbon.
hydrocarbon possess. And we only have one example. What's the example that we have?
Benzene.
Benzene. And this benzene
Okay.
is written in different forms. So in different what? In different forms.
Different forms.
What are the forms that? But normally, they do from the scientist point of their view. They said it is written in two forms. It is written in what? In two forms.
Two forms.
Yes. So number one, if you want to write a benzene is C6H6. C what? C6H6.
H6.
That's the benzene. And what's benzene? How do we write it? This is how we write it. It is in forms of cyclic. You know they are cyclic. Cyclic means that they are cyclo.
Yes, sir.
Yes, sir.
That is, when we said something is cyclo, that is, it is found in rings, right?
Yes.
Yes.
Yes, sir.
So this is benzene. We have carbon, 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 and carbon. But the way we write the structure, why it is planar, the planar and the Huckel's rule, it means that inside benzene, we must have 3 double bond. 3 what? Double bond.
Double bond.
So, yes, we have it here. You might not have it here. You have it here. Sorry. You have it here. You don't have it here. You also have it here. So, some people also draw it like this. That we have it here, not here, but have it here, not here, and have it here. Are we together?
Yes, sir.
So now, in this case, are they different?
No, sir.
Why?
Because they are C6 and both of them is C6H6.
I know it is yes. Okay. Now, this carbon itself, it is surrounded by how many bonds?
Which one?
This
Surrounded by three. Three bonds.
1, 3, right? It remains
Yes,
how
sir.
many items? It remains one, right?
One. Yes, sir.
This one has 1, 2, 3, right?
Yes, sir.
This one as well. 1, 2, 3, right? This one as well.
Sir.
1, 2, 3,
One, two,
right?
three.
This one as well. 1, 2, 3. 1, 2, 3.
It's
Fine.
complete.
Do we all understand how we get 1, 2, 3, 1, 2, 3, 1, 2, 3?
Yes.
Yes,
Yes,
sir.
sir.
Out of this one is also the same thing as well. So, but what I need from you is that you should tell me that the position of the bond is quite different. What differ in them is the position of bond. They possess the same thing, but the position of bond here is quite different from here. It is on this side, right? That shows that they are still the same thing. It's just the position of the what? Of the bond.
Bond.
So now scientists now said for this one to be positioned differently. So what you can say is that this one is still the same thing. Nothing differ. Nothing what? Nothing differ. Why we said nothing differ is that in isomerism, we have the so-called, you should have heard about it, optical isomerism, right?
Yes, sir.
Optical isomerism. Optical isomerism means is an isomerism whereby the carbon atoms itself is surrounded by 4 different groups. It's surrounded by what? 4 different groups. So, but yes, it is being placed in a plane mirror. For example, when you are looking at the mirror, it means that your left side is slightly different from the right side in the mirror. Who can we identify that? When you are looking at the plane mirror, your right side there in the mirror, it becomes your what?
Yes.
Your
Left side.
Left hand. Yes.
That also.
Yes,
So
sir.
that's actually why they said these are the same thing. So it means that when they place this at the mirror, it means it will show these inside the mirror. Is that not so?
Yes. Yes, sir.
Yes, that's actually why they said they characterize it as one thing. So it is just one. So the second thing, how do we represent the second benzene that we do have? The second one that we do have, sorry, the second one that we do have is this. Don't mind my drawing. I don't know how to draw. Wow, you have this at the middle. So this is benzene. This is also what? Benzene. When you see this, so note that they're actually talking about what? Benzene. This is the two form of writing benzene. Are we together? This is the aromatic hydrocarbon. We also, because we have some type of benzene. We have phenol, we have aniline. They are just subtype of benzene. Are we together? So we are still going to explain that. You are going to know that in this class. So let's just, I think here we stop. So is there any question?
What is the definition?
Please speak aloud. I can't hear you, sir. Hello, sir. Mr. Rocky. Are you talking to us? I said any question? Okay.
Oh, no.
He's not talking to us.
It's on phone.
Yes, sir. Okay. No question from us, right?
Yes, sir. Yes, sir.
Okay. We all understand what we did today.
Yes, sir.
Yes, sir.
Okay, in the absence, okay, in the presence of none, so none, we don't have question. So thank you very much for the class. Thank you for your cooperation. So we meet in our next class. Right?
Jazakumullah khairan.
All right. Let's take care of ourselves. Read very well. Yeah.
Hmm?
We can't hear you, Adebi. Adebi Berokin. We
Is
can't
there
hear
when
you.
is it coming for his iftar? Okay.
Okay. Okay, Ali Daya, you have a question. Ali Daya, you have a question? You raise up your hand.
She's not here.
Okay, I don't think she has a question.
Maybe it was the mistake.
Okay, it was a mistake. Okay. All right. Let's take care of ourselves. Let us read very well. All right. Assalamu alaikum.
Alaikum salam.
Waalaikumsalam.
وعليكم السلام ورحمة الله وبركاته.